Welcome, students. Today, actually, we are going to discuss the second concepts of that one kinematics chapter. In the last class, we have discussed what is distance, okay, and what is displacement. But today, we are going to discuss actually basically from that motion in one dimension. The second concept, we have to understand what is speed, what is velocity. Okay, today we'll try to understand it well. And as you know, my name is Amarnath. Well, today, before starting the actually speed, so let's recap on what is distance. Okay, what the distance is, and the displacement is as already in the last class. Okay. Say from this point, I am going through this zigzag path to this point, okay? The exact path length, okay, 1 meter, 2 meter like this, that will be the distance. Well, but the shortest path length from point A to say B, that shortest path length is called displacement, okay? Displacement is vector quantity and distance is scalar quantity. We have already discussed, okay? But because actually speed and velocity actually defined by that distance and displacement only, and that is why we should properly know what is distance, what is displacement. That is why I have given a little recap. Now let us discuss what is speed. Actually, definition of speed is rate of change of distance. Okay, you have to just learn it, nothing else. The rate of change of distance is called speed. You can say the distance by time. Okay, in general you can say distance by time. But say I have to go from point A through this zigzag path to point B, okay? The whole path will be the total distance. But if I ask you what will be the, say, speed of my car at a small distance in between the path, okay? So let us take one small gap, okay? This is the gap. So this gap is very small, no? It is very, very small, infinitesimally small. If the total distance is s, I will take the small distance is ds, okay? So remember, ds is just an operator, huh? D is an operator. ds is, it doesn't mean the d into s. ds means very, very small s, okay? Say on the path, I have taken a very, very small distance, okay? Very, very small s. So obviously the time taken to cross this very, very small distance also will be very, very small only. So here dt is what? That is very, very small time, okay? Very, very small time. So what is ds by dt? So ds by dt will be the speed of my car at this position, okay? At this position. The average speed may be total distance by total time, but that speed at this position will be distance of this position divided by time taken to cross this distance, okay? So that is called instantaneous speed. Actually, that is called instantaneous speed, means speed at an instant, okay? So that definition you should understand actually. So instantaneous speed is what? That is simply ds by dt. We have to remember this, okay? And we call it differentiation of s with respect to time, okay? Actually, we have already discussed the basic in basic maths, what is differentiation. So we call it, actually, we read it, differentiation of ds by dt means ds by dt means very small distance by very small time. We read it as differentiation of distance with respect to time. differentiation of distance with respect to time. Okay, so this is a big formula. We should better keep it in a box. Okay, and remember, this is also called actually slope of the graph. Say this is the graph of distance. Okay, so this is distance graph, this is time. Say graph is like this. So what is ds by dt? You see, if I take a small this time dt here and a correspondingly small distance here, so in this triangle you can see that the small triangle, that a small triangle, this is called distance, this is called time. So ds by dt, this is nothing but tan theta only, na? ds by dt is nothing but tan theta only. And this is also called actually slope of st graph. This is also called slope of s versus t graph. Okay. So I have to learn these three things. V equal to ds by dt. Okay. Then ds by dt means tan theta, perpendicular by base. Then ds by dt means slope means perpendicular by base. Huh? Slope means just perpendicular by base. Say this is a triangle. So this is perpendicular. This is base. This is theta. So dy by dx is tan theta, and this is also called slope. You see, if dy is less, this line will be a little bit inclined. Na? If dy is more, see, this is a horizontal line, so its slope is 0. This is little bit inclined, so it will have some slope. This is more inclined, so it will have more slope. This will have infinite slope. Vertical line has infinite slope because tan theta, tan 90 is 0 because this is 90 degrees. Na? This is the theta. So as the slope goes on, means graph will go on like this. Okay, horizontal graph, slope is 0. And because as remember, I have told you all these things because from every point we are going to practice some numericals. From every point we are going to practice some numericals. Again, you see, if v equal to ds by dt, so ds equal to what? V into dt. ds differentiation means breaking into small segments, and integration means adding all these things. Okay, so this is s. If I break into small segments, one small part is called ds. ds means very small s. But if I integrate it all ds, so I get s. Okay, integration symbol is this. Integration symbol is like this. So here you see, as v equal to ds by dt, so it means ds equal to v into dt. So if I integrate it, so what I get? Integration of ds is s, means integration of vdt is nothing but total distance traveled. Okay. So get ready for a question. Okay. The distance traveled by a particle varies with time as s is equal, s for distance, 3t square plus 5t meter. Okay, t is the time. Find the speed of the particle at t equal to 2 seconds. Okay, so you see, first of all, you are given that distance equal to distance equal to 3t square plus 5 into t. See, time cannot, time always flows forward. That time increases, so your distance is increasing. So it means the particle is in motion. Okay. So as the particle is motion, so it must have some speed. It is genuine. Okay. We are going to calculate the speed at t equal to 2 seconds. Okay. So how you see? We need t speed at t equal to 2 seconds. Means we need instantaneous speed. Remember, we need speed at 2 seconds, at dot 2 seconds. Means at that instant. So that is a instantaneous speed. We know that speed equal to differentiation of distance. Okay, we know it. So speed equal to d dt of differentiation of this thing. Okay, it is simple differentiation. So speed equal to 3 times d dt of t square plus 5 times d dt of t. The speed equal to 3 times t square differentiation is 2 into t to the power 1. Okay, because you know that t to the power n differentiation of t to the power n is what? N t to the power n minus 1. So here it is t square. So it will be 2t 2 minus 1. So 2t. And here it is dt by dt only. So it can easily be cancelled only. Na? dt upon dt will be 1. Okay. So it means v equal to 6t plus 5. Okay. So this is the general expression of speed with time. Okay. But we are asked to calculate the t equal to 2 seconds. Na? So therefore at t equal to 2 seconds, v will be 6 into 2 plus 5. It means v will be 6 2 are 12. 12 plus 5 is 17. So it is in meter and it is in second. So answer will be meter per second. If check the calculation part, and I hope it is correct. Okay. Try to understand it and copy it also. Okay. If you have any trouble in any steps, feel free to ask me. Okay.
Sir, we cannot simply substitute the t is equal to 2 in that equation, sir.
Where? Which equation? First equation.
In that 3t squared plus 5t, we
No,
cannot
this
substitute
is
t
not
is equal
speed,
to.
na. This is distance only, na. So if you put 3 into 2 square plus 5 into 2, so you are going to get distance only. 2 to the 4, 4 to the 12, 10. So it will be the total distance traveled in 2 seconds. Okay, it is not the speed at that moment. Okay, because you know the distance
Okay.
is different, speed is different, na beta.
Yes, sir.
Okay. Try to that understand and grasp also, huh? Because I am going to give you one example exactly similar, okay, with a little bit difference only, little bit difference. Okay, you can say 90% same. So can I rub it?
Yes, sir.
Okay, see this question, next question is for you. I am changing it little bit. Please try it. I am giving you 2 minutes. Speed equal to ds dt of 5t cube 2t 5 dt of t cube. See, after we become expert, we can remove lot of terms. Okay, but now we have started practicing only. So it is 3t square. it will be 15 t square plus 2. So this will be the general expression of velocity, okay? If you put t equal to 1, you are going to get some different answer. If you put t equal to 2, you are going to get some different answer. So at t is equal to 1, speed is equal to 15. So it is 17. Is it okay?
Yes, sir.
Nice. Nice. Then let us change the flavor, okay? Now actually we are coming in reverse. We are given the speed now, but we need to calculate distance, okay?
So we have to integrate it, sir.
Yes, yes. Here actually I have to integrate it. The speed of a particle varies with time, v equal to 3t cube plus 2. Means at different time, it has different speed. Find the distance it travels in first 1 second, okay? So what is the relation actually? We know that v equal to ds by dt, but we require ds, but we do not require even ds also. We require total distance. So when the time was 0, there was no distance traveled. When the time was t, the distance is s, okay? We can say that the integration of ds is s only. So we can put lower limit, upper limit. Okay, this is the rule. And this is v. V is nothing but 3t cube plus 2 into dt. Okay. So this part is nothing but s minus 0 is s only. And here it is integration of t cube dt plus integration of dt. And already we integration of dx is x. So integration of dt is also t only. And integration of t to the power n dt, already we have discussed that it will be t to the power n plus 1 by n plus 1. So on that context, it will be t to the power 3 plus 1 means 4 divided by 3 plus 1 means 4 plus 2. At that context, it will be dt only, okay? And remember, I have to put the limit also 0 to t, 0 to t, 0 to t. So here 0 to t, 0 to t. So it means the formula will be finally s equal to 3 by 4 t to the power 4 minus 0 to the power 4. So it will be t to the power 4 only plus 2 t minus 0 means t only. So this is the expression of distance. It is the expression of distance, okay? Again, I remember you should understand that if I differentiate it, I am going to get this velocity only, okay? If you differentiate this term, you are going to get velocity only. But the question is in first 1 second, no? So actually this t is 1, okay? Therefore, at t equal to 1, distance equal to 3 by 4, 1 to the power 4. So it is nothing but 3 by 4 plus 2, 11 by 4 meter, okay? All are in SI. You see, just you if you want, you can directly get this answer also now without taking the limit between 0 to t. You can directly take the limit 0 to 1 also, okay? In place of t, you can put 1 and directly get the answer. But still, for practice, I am just giving the expression as a function of t. And you also try to solve that way only, okay? Because later we have to draw graphs also. We have to write general expression also now. that will be required. So that is why keep practicing this way only, whatever I told you. So do you have any trouble? Can I go to the next question? It will also be exactly similar question. Okay, you can hit it.
Yeah, why are we using the upper limit and lower limit?
Pardon?
Why are we using the upper limit and the lower limit?
Because you see, they have said what is the distance traveled in first 1 second. Okay, say this is t equal to 0. At t equal to 0, say particle is here. So as the time passes, the particle going. Okay, so at this is t equal to 1. Here it is t equal to 2. Achha, if the meeting gets over, you click on the same link and join back. Okay.
No, sir.
Okay. Now you see we need to calculate the distance between this point and this point. Okay. So this is the distance. Okay. So it means this is the lower limit and this is the upper limit. From where to where we need to calculate. Na? This is nothing but a limit. Na? They have asked first 2 seconds. If they asked what is the distance traveled between t equal to 2 and t equal to 4, what is the distance?
4 by 2.
That will be
Upper
2,
limit
that will
is
be 4.
4.
Okay.
Yes, sir.
Good. Keep asking. Okay, like that. So try the next question. This is also first 2 seconds. First 2 seconds means 0 to 2 seconds. The speed of a particle varies with time as v equal to 2t plus 1. Find the distance it travels in first 2 seconds. We know that again ds equal to what? ds equal to v dt. So it means integration of ds, integration of v dt. Okay. That velocity when time was 0, the velocity distance is 0, and when time is t, or you can directly put 2 also, no problem. So this is 0, this is 0, this is s. So the left part will be s only, and v dt, that is 2t plus 1 into dt 0 to t. So it means s equal to t dt, integration of dt. So again, integration of t dt means always t square by 2. Because t dt means t to the power 1 into dt. So it will be 1 plus 1, 2. 1 plus 1, 2. So that is t square by 2. And this is t only. So t square by 2. Now the limit is 0 to 2. No? 0 to 2. You can directly put the limit also, or otherwise you can put the value only. Okay. Here actually t equal to 2. Yes. Excel. No, t square plus 2. It will be 6.
6, sir.
Okay. Find the distance level. It will be the distance will be 6. Okay. Till that it goes down up to 6 meter. Okay. All are in SI, so it will be meter only. Okay. Let us change the test. Okay. Test of question now. Now let us try one graph. Okay. Try to understand. Say, try to understand the graph first. Huh? Say this is time axis. Okay. Starting from 0. And this is say distance axis. So I am going to draw a graph distance versus time. Okay. Say the graph is like this. This. Okay. Like this. Okay. And I have given you the that one also coordinate. Okay. Say this one is 3. It means 3 meter. You can say. Okay. Say all are in SI. This one is say 2. Okay. 2 second. This one is say 4 seconds. This one is say 7 seconds. And that is say correspondingly 6 meter. Okay. All are okay. This is the graph. Okay. Now, what is the question? I'll ask you speed at different points. Okay. The distance in meter traveled by a particle varies with time as shown in the graph. Find the speed at t equal to 1 second. So remember, graph is a speed time graph. Okay.
Yeah. So we have to find the slope.
I have to find the slope at t equal to 1 second. So t equal to 1 second is somewhere here. Okay. So as it is a straight line, so slope will be same only everywhere. As it is a straight line, so this slope, all slope will be same only, the same straight line. So what I do, I calculate that big slope, okay, perpendicular by base. Velocity at t equal to 1, it will be nothing but the slope, okay. That slope is nothing but perpendicular. Perpendicular is 3 minus 0. Because this point is 3, this point is 0. So final minus initial. And time is 2 minus 0. So it means 3 by 2 meter per second. Do you have any doubt?
Sir, they have asked to find at 1 second what would be the speed, but we have calculated with 2, no, sir.
Because it is same, na? Said as this is, no, I have not calculated 2. I have calculated the slope between t equal to 0 and t equal to 2. You see? This is t
So
equal
it
to
is
0.
constant
This
throughout
is
that.
constant. If the graph had been like this, na, then slope will be different. Here the slope is this, here the slope is this, here the slope is more. Okay, gradually slope is increasing. If the graph is like this, then the gradually slope is decreasing. Okay, here the slope is 0 only. Okay, but now
Yes, sir.
this is a straight line. Straight line. So as it is a straight line from here to here, so everywhere the slope will be same.
Constant.
Constant. That is why. Fine, Vita?
Yes, sir.
Good, excellent. So what you do one thing, you try the next question. Okay, I am adding one more time. Say you need to find out the t equal to 3 seconds. What will be the speed? Find the speed of the particle at t equal to 3 seconds. Okay, my aim is to calculate the slope at t equal to 3 seconds. So t equal to 3 seconds, 3 seconds is somewhere here. And I can see that the graph is horizontal only, okay? See, if the graph is like this, so this will be perpendicular, this will be base, okay? So this will be dy, ds in our example, it is nothing but ds only. So this is ds by dt, okay? This will be the slope. Okay. But if the graph is little bit tilted like this, so ds will be less, na? You see? ds by dt. Theta will be less, na? So it means slope also will be less only.
Yes, sir.
If the graph is horizontal only, so ds. If the graph is horizontal only, it means there is no perpendicular part. So ds by dt will be 0 only. Has to be tan theta, tan 0 is 0 only. If theta is 0, so it means at this position slope is 0. So it means at t equal to 3, the speed at t equal to 3 equal to what? 0. It means particle is stationary. See, at t equal to 2 seconds, particle is at a position 3. Okay. At t equal to 4 seconds also, particle is at a position 3 only. So what does it mean? Particle is stationary, na?
Oh, so sir, we can also use that form, right? S2 minus S1 by T2 minus T1.
But x2 minus x1 will be 0, na? S2 minus s1. S2, see, S final, if you want to apply that way also, S actually, remember S1, it comes, actually, it becomes the average, actually, okay. But then also it will be 0 only, because you see S final minus S initial by T final minus T initial. Now you see S final. So T final is what? 4 minus 2 only. Final 4, initial 2. But S final,
For distance 3 minus 3.
3 minus 3 only. No? So it will be 0 only.
Yes, sir.
Understood? No?
Yes, sir.
Both way answer will be same only. You please try. Verbally, can you try to give answer at t equal to 3.5 second? What is the answer?
The same, sir. 0
0. Very good.
meter per second.
At t equal to 1.5 second, what is the answer?
3 by 2 second. Meter per second.
3 by 2 meter per second. Very good. Now you please try t equal to 5 second. Okay. Take some time. So t equal to 5 second is somewhere. Say this is 5, this is 6. So it is somewhere here. Okay. So I need to calculate the slope at this point. But as it is a straight line, so everywhere slope will be same only. So what I do, I extend this and I extend this. Okay. So this part's length will be 3 only. Because this point is 6, this point is 3. Okay. So 6 minus 3 is 3 only. And this part's length will be 7 minus 4. So this is also 3 only. So it means that slope equal to at t equal to 5, speed equal to, it is nothing but slope only. So it is slope 3 by 3, which is 1. Why 3? Because this point is 6, this point is 3. 6, 3. So the gap is 3. This point is 7, this point is 4. So the gap is 3. Okay?
Yes, sir.
Okay. So now we are going to change the flavor. We are going to calculate the area, okay, for the next question. Say, again, similarly, this is a time axis starting from 0. You also draw this, graph is almost similar only. But this time it is V, Earlier it was this is distance, this is speed, okay? Graph is like this only, okay? That is 2, that is 4, that is 7, that is 6. So what is the question? The speed in meter per second of a particle varies with time as shown in the between t equal to 0 and t equal to 2 seconds, okay? It means, say this is t equal to 0, this is t equal to 2. In that period, how much distance is traveled, okay? Time is 2, but distance is 1. Remember, speed time graph. So we should understand that area under speed time graph gives us distance, okay? Because I have already discussed ds equal to v dt. Integration of ds is integration of v dt. So integration of ds is s, and this is nothing but area. Integration of v dt means area. So total distance equal to area under, below, under V versus T graph. So I need to calculate between T equal to 0 and T equal to 2. So this is T equal to 0, this is T equal to 2. So I need to calculate this much area only. So S equal to, if it is a triangle, half into base into altitude. If it is a rectangle, it will be length into breadth. If it is a square, to length is square. It will be, if it is a trapezium. So you know how to calculate the area of trapezium, I think, na? Half of the sum of the parallel side and into the
Into
separation.
distance between them. Yes, sir.
Like that. If it is circle, then pi r square like this. So it will be half into base into altitude. So it means distance equal to 3. Is there any doubt?
No, sir.
So if I calculate between 2 and 4, you need to calculate this part. If I ask to calculate 0 to 4, it means you take the triangle as well as the
Rectangle.
So I am asking you, okay, one more part, okay. Second part, you please try to do it. Try to find out T equal to 2 and T equal to 7. T equal to 2 second and 7 second. Means from here to here. So I need to calculate dispersed area and dispersed area, okay. The total distance is area 1 plus area 2. So area 1, this is simply a rectangle, no? So its breadth is 2 and height is 3, I think, no? So 3 into 2. And here it is actually a trapezium, okay? So it is half of the sum of the parallel side. This is 3 only. And this is 6. And the perpendicular distance, it is 3. Am I okay? Into 3, no? So it will be 6. 27. 27 by 2. Twenty-seven by 2 means what?
13.5, sir.
It is meter, okay? So that way you can calculate the distance using graph also, okay? So bye bye for today.